Assalamualaikum warahmatullahi wabarakatuh, and thank you to Dr. Siti Hajar for giving us opportunity to have this video presentation about distributed control system. So we are from group 2, and this is our group members Farhan, Hamizah, Fazleen, and lastly Adliah. So what will be covered in this video presentation is what is distributed control system, which will be covered by me, Farhan. Next is how it works will be covered by Hamizah. Advantages and disadvantages will be covered by Fazleen, and lastly example of DCS will be covered by Adliah. So let's move on to the first topic, which is what is distributed control system. Distributed control system is a system of sensors, controllers, and associated computers that are distributed throughout the plant. Each of these elements serve a unique purpose, such as data acquisition, process control, as well as data storage and graphical display. These individual elements communicate with a centralized computer through the plant's local area network, often referred to as a control network. As the central brain of the plant, the DCS or distributed control system makes automated decisions based on the production trend. It sees them in real time throughout the plant. As an example, the distributed control system at a power plant might automatically increase the steam generation capacity of a multiple turbines in order to keep up with changing demand for electricity during hot summer days. And then they will decrease it as outdoor temperatures cool overnight and demand subsidies. So in distributed control system in the power plant, they will increase the electricity generation based on the demand. If the demand is high, then they will increase the electricity generation. So as you can see in the video, this is the level in the distributed control system. The level is, we know that it is multi-level. So I think this is basic one. I think it is more complicated in the industrial. So I will explain about the level in the distributed control system. So this is the level in the distributed control system. The first level is level 0. What contained in level 0 is the level 0 will contain field device such as flow and temperature sensors, and final control elements such as control valve. Next is level 1. It contains industrialized input-output I/O modules and their associated distributed electronic processors. Next will be level 2, contain the supervisory computers, which collect information from processors nodes on the system and provide the operator control screen. Next, level 3 is the production control level, which does not directly control the process, but is concerned with the monitoring production and monitoring target. And lastly, level 4 is the production scheduling level. So this is all the component inside each level. So I will pass to Hamizah, and she will explain more detail how does distributed control system works.
Okay, now we're gonna look at how this system works. So basically in this DCS system, we have 4 basic elements. Okay, we're gonna start from the operator station first. Okay, basically this operator station is the heart of the system because this is the ones that observe the operation, view process warnings and alarms, and also monitor the production. Then we're gonna move here, which is they have the server, archive, and also engineering station. So this server is used for the collection of data at the processor level, which is at this level. We're gonna see at this later. And then these archiving computers are used for storing historical data, and the engineering station used for creating the project. Okay, basically this operator station is connected with this by using the communication media that we call as industrial Ethernet. Okay, now gonna move to this level, which is processor level. They have the master controller over here. Basically, in this DCS system, the controller are distributed throughout the entire plant area. So this controller, their function is to providing the data to the server, which is here. Okay, next we're gonna continue with the field device level. So as you can see, this processor level and also this field device level are connected by the communication media, which is Profibus DP, fiber optics, industrial Ethernet, and also Ethercat. So, but basically, this communication media is depend on the number of devices to be connected to the system. Okay, so on this level, on this field device level, this is actually where the sensors and also actuator are located. They are located at this level. So on this level, we have the distributed I/O. So this distributed I/O will receive measurement signal from sensors such as temperature, flow rate, and the output signals will send to the final control elements. So basically, this I/O will collect the information from this field device and will send to the engineering station or to the operator station. This also will receive the instruction from the engineering station, like set point, and will directly control the whole field service.
Next, I will explain about the advantages and disadvantages of distributed control system, or DCS. For advantages, firstly, the integrated monitoring and control system of DCS is similar to today's SCADA systems. SCADA stands for Supervisory Control and Data Acquisition. This is because the entire tech base is in DCS that is already created for the process control and also available to be used on the monitoring and control screens. Secondly, DCS has function block programming. Block programming defined as several lines of code behind a single interface. The function of interface is to handle the manual and automatic operation of a valve. And also function block programming save a lot of time and redundant programming. Next, the advantage is on installation costs. This is because of the location of the autonomous controller to the process can be close in vicinity versus pulling long runs I/O wire across a plant. It also reduces the installation cost by localizing control functions near the process plant with remote monitoring and supervision. DCS were attractive because the DCS manufacturer would supply both the local control level and central supervisory equipment as an integrated package, so that it can reduce the risk of design integration. Also, DCS has onboard monitoring and control system so that it will save the development time. Then DCS have several autonomous controllers, so if one controller fails, it will impact only that process and not the entire process. Or if a controller fails, the entire the entire plant does not get impacted. So DCS is better used in an environment where there are large I/O counts with many continuous process, and a processor failure in one section of the plant is not problem for production. Then the first disadvantages of distributed control system is processing times in DCS are much slower compared to SCADA. Next, DCS required skilled operators since all the information is hidden behind the CRT. CRT acts as the operator interface that give many advantages to the control and operation of a plant process. However, CRT may lead to operator errors and also reduce the operator performance. Then it will cause plant upsets and loss of life.
Hi, I'm Adliah and I'm going to talk about the example of distribution control system DCS. These are the examples of application DCS system. Firstly, we have oil and gas industry. Next, we have food processing industry. Then, we also have water treatment system, nuclear power plant, and pharmaceutical manufacturing. So why this industry use distributed control system DCS? It is because DCS is used in manufacturing processes that are continuous or batch oriented. Next, because DCS have large number of control systems that can help to monitor and control the complex processes in these industries. So we can see from this picture that DCS does have large amount of control system compared to PLC that can only control one process, one part of process. So in DCS, if one of the CPU have a failure, the other CPU can still continue performing their function. Next, I'm going to explain about DCS in oil and gas industry. So in oil and gas industry, automation control system, which is we referring to DCS, are important to ensure the accuracy and precision. DCS offering improved control over the production process. In oil and gas industry, it is a process-based industry and is a continuous operation and complex monitoring processes. So DCS help operator to control operation with the help of human-machine interface, HMI, and controller. So what is human-machine interface, HMI? So in DCS system, HMI is used to help operator control and monitor machine by using touchscreen that are connected to the machine. So the example of HMI that we usually use is ATM machine. So when we touch the screen, the machine will start to work. Okay, this is the example of HMI screen. So it is really useful for the operator since they can see what is happening in the production. So they can see the level of the water inside the tank, the temperature inside the tank just by using HMI.